Hello, PreCalc. Here we are with 4.3 today. We got some right triangle trigonometry. You guys have done this in geometry and in Algebra 2, so I'm probably going to breeze through these notes pretty quick because, as you can tell, the voice is not the strongest. Okay, so we know about SOHCAHTOA, sine, cosine, tangent. We got sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Remember that opposite and adjacent are based on the angle that you're using. Alright, if I'm using this angle, this side's opposite, this side's adjacent. If I switch to using this angle, now this one's the opposite and this one's adjacent. Hypotenuse will always be the one across from the right angle. Alright, so we talked about sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. And then their partner functions are all going to be flipped. Hypotenuse on top, adjacent over opposite. Alright, we talked about that already. Okay, let's see here if you can come up with these. Now you're going to have to use a little Pythagorean identity here, or Pythagorean triple, to come up with this. Go ahead and push pause and see if you can come up with these on your own. Alright, welcome back. So, we got a right triangle. We got the two legs. We don't have the hypotenuse. We have A and B. So 3 squared plus 4 squared equals C squared. 9 and 16 makes 25. That is C is 5. Okay, so this is 5. So now I can do sine, cosine, tangent. Sine is opposite. Here's the angle that I'm using. So opposite is over here. And then this one's adjacent, and that one's already labeled hypotenuse. So sine, we have opposite over hypotenuse, 4/5. Cosine, we got adjacent over hypotenuse, 3/5. Tangent is opposite over adjacent, 4/3. Okay, their partner functions are just going to be flipped. So we're going to have 5/4, 5/3, and 3/4. Alright, piece of cake. Onward. Back to our unit circle. Bum, bum, bum. Okay, sine of 30 degrees equals a sine of 5 or 6 equals a half. We did all those. That's what the whole lesson was last time, was talking about unit circle stuff and knowing those things. Okay. Notice that sine of 60 and cosine of, or sine of 30 and cosine of 60 are the same. Same thing for cosine of 30 and sine of 60. Okay. That's because they are complementary angles. In general, it can be shown from the right triangle definitions of cofunctions of complementary angles. That is, if theta is an acute angle, the following relationships are true. Sine of 90 minus theta will be the same thing as cosine of theta. So cosine of 28 will be the same as sine of 62. Okay? Stuff like that. We already know those. Sine equals 1 over cosecant. Cosecant equals 1 over sine. Cosine is 1 over secant. Secant is 1 over cosine. Tangent 1 over cotangent. Cotangent is 1 over tangent. Tangent is made up of sine over cosine. Okay, cosine is, or cotangent is cosine over sine. Here's some good ones. Pythagorean identity. Sine squared plus cosine squared equals 1. That was one of the main things from Algebra 2 when we worked on trig. And then we also have those two. Okay, let's get into a good one here. let theta be an acute angle such that sine of theta equals 0.6. What would cosine of theta be? And then find tangent of theta using your trig properties. Okay, so if sine equals 0.6, sine squared plus cosine squared equals 1. I don't write the thetas in there. Sorry, wow, way off the screen. I don't write the thetas in there because those turn into zeros for me, and then it messes up my problem. If you want to write them in there, go for it. Okay, so we got 0.6 squared plus cosine squared equals 1. 0.36. Okay, subtract that over. We're going to have 0.64. It's a Pythagorean triple, but with decimals. Instead of looking at it as 6, 8, 10, we got 0.6, 0.8, and 1.0. So we're going to subtract that 36 over 0.64 square root. Cosine equals 0.8. Alright. It says an acute angle and sine is positive. So I think that's kind of limiting us to the positive quadrant here. Quadrant 1. Okay. Find tangent. Well, tangent is sine over cosine. So we have 0.6 over 0.8. That's 6 over 8. That's 3 over 4. That's going to be 0.75. Keep it moving. Alright, let B be an acute angle such that tangent of B equals 4. Find the values of cotangent and secant using trig identities. Okay, so it is the same kind of deal as one of these, but now we're over here. Okay, so we have tangent is 4. Alright, so if tangent is 4, cotangent should be 1/4. Alright, let's not overthink that one. And then now, to get secant, we can use 1 plus tangent squared equals secant squared. Alright, so we got 1 plus 4 squared equals secant squared. 1 plus 16 equals secant squared. 17, we're going to square root it. And I think we're just taking positives. Acute angle, it doesn't really tell us a whole lot. Tangent is positive, so that's first and third quadrant. So I think we're just taking positive answers for these. I don't think we have to really think yet about what quadrant we're in. I think we're just staying in quadrant 1. Secant. Use a calculator to evaluate secant of 5 degrees, 40 minutes, and 12 seconds. Wow, that's kind of crazy. Alright, you don't have a secant button on your calculator, so what you are going to do is 1 over cosine of all that. And yes, you do have all that on your calculator. Let's see where it's at. Okay. Let's go with cosine of 5 degrees. And how do I get the degree sign? That is second apse. See the little angle thing above that? And there is our degrees. We have 40 minutes. And that was also right there, second apse, to get to the angle menu. And then, you know, it would be convenient if seconds was in there too, but it's not. But I think you've seen that around before. Where did it go? Yep. It's alpha plus. Alpha plus. It has the double quotes. All right, we're going to close it up. And then reciprocal, because that's cosine, so that secant is going to be the reciprocal. And there we are. 0049. Okay, that was, we'll get 60 minutes in 1 degree, 60 seconds in a minute. Okay, and our angle sign, our degree sign, make that a little smaller. Degree sign is second apps, and then it's the first option, and then the minute is second apps, and that's the second option, and then seconds is alpha plus. All right. Okay, applications involving right triangles. We have the angle of elevation, where you are on the ground looking up. Angle of elevation is how far you move your head, how far you move your eyes. Looking straight ahead to how far do you move your eyes up. Angle of depression is how far do you move your eyes down, how far do you move your head down. Okay? Let's see what we got for examples here. Hopefully not much. The voice is on the edge here. We might just do like 1 or 2 of these. All right, we are 115 feet from the base of the Washington Monument. The surveyor measures the angle of elevation to the top of the monument to be 78.3 degrees. How tall is the monument? Okay, so he's 115 feet away. That angle is 78. Let's assume this is a right angle. Okay, so from this angle, we have adjacent, we want opposite. So we're going to use tangent. All right, so we got tangent of 78.3. We're in degrees now. So make sure, I know we've been using radians, so make sure you change your calculator back over. Opposite is y over 115. Going to multiply both sides by 115. Make sure I'm in the right mode. Degree mode, yep. 115 times tangent, 78.3. 555.3 feet. All right. Wow. Well, 9 is really easy, but 8 is going to take a while. Where are we at for time? 14 minutes. All right, we'll try 8, and then we'll just be done. Okay? You can read example 9 in the book. In traveling across flat land, imaginary land, two-dimensional space, you notice a mountain directly in front of you. Its angle of elevation to the peak is 3.5 degrees. After you drive 13 miles closer to the mountain, the angle of elevation is now 9 degrees. Because you're closer, so it's a steeper angle up to the top. Approximate the height of the mountain. Interesting. Okay. This is a good one. So here's our picture. And by good one, I mean a really tough one. A lot of details. So we got 3.5 degrees there. We got 9 degrees here. This little piece is 13. I don't know how far this one is. We'll call that Y. Well, that makes more sense. Well, we're going to call it Y because the answer key I'm looking at here that from before called that one Y. I don't want to flip-flop the letters and then mess this problem up. Okay? So, from tangent of 3.5, we can say that is x. Opposite is x over 13 plus y. Alright? And then tangent of 9 equals x over y. We're going to multiply this y up. Y times tangent of 9 equals x. And now we're going to substitute this in and do a little substitution. Equals y times tan 9 over y plus 13, or 13 plus y. Multiply this quantity up. Okay. Distribute. Alright. Now, the goal is to get the y's on the same side, so we're going to subtract this one over. Y tan 9 minus y tan 3.5. And we'll factor out the y. And then you're going to divide by that mess. So we're going to have 13 times tan 3.5 divided by the quantity tan 9 minus tan 3.5. And that's equal to y. And then divide that by parentheses. Nope, close them. Wow, look at all those mistakes. Close your parentheses. Minus tan 3.5. Close that parenthesis, close the main one. Yep, I think that's it. 8.18. So now that is 8.18 over here, and now I can use that. Tangent of 8 degrees equals x over 8.18. 8.18 times tangent of 8 . 1.15 miles. How about that? Woo! Absorb that in. There's a lot of math there. Pretty tricky with that substitution over here. And then a lot of details, keeping everything straight. And then the last piece is really easy. Okay, again, example 9 should be pretty easy. You can look that one in the book. Well, Here's the answer key that I'm looking at for that one. Okay, you go ahead and push pause and look at that, but I'm not going to talk through it. The voice is given out, and we are at 20 minutes. All right, there you go, folks. Best of luck. Hopefully I'll be seeing you soon.